After months of planning and preparation, we're finally starting the build of the giant C-17 Globemaster, one of the biggest and craziest projects we've ever taken on. With a wingspan of nearly 6 meters and a workshop packed with advanced fabrication equipment, this massive idea is finally becoming reality. The journey ahead will definitely be challenging, but if everything goes as planned, the final result will be absolutely incredible. So now, let's begin the journey of building this giant C-17. After completing the EPS foam structure and reinforcing the aircraft body with fiberglass layers, we moved on to building the rear load-bearing support frame using precision CNC cut plywood. Every component was carefully measured, cut, and assembled to create a strong internal structure for the giant C-17. The entire fuselage surface was then hand-sanded and coated with multiple layers of carbon fiber, fiberglass, and epoxy resin to increase rigidity, create a seamless outer shell, and strengthen the overall aircraft structure. To create a rigid structure for the giant 6-meter-long C-17, we assembled and bonded CNC-cut plywood frames inside the fuselage. Each bulkhead was carefully aligned and connected to the load-bearing beam system to form a strong internal skeleton for the entire aircraft structure. Load-bearing carbon rods were installed through both sides of the fuselage to reinforce the wing structure and central mechanical system. Every mounting point was carefully measured, drilled, and aligned, while the plywood frames and carbon rods were securely fixed together to create a rigid, seamless structure ready for the tail assembly of the giant C-17. Similar to the front section, the rear tail assembly, along with its aerodynamic control surfaces, is fabricated from a technical foam core, which is then bonded using specialized adhesives and reinforced with multiple layers of high-performance composite materials, primarily carbon fiber and fiberglass. The entire surface is laid up with multiple carbon fiber layers to enhance structural rigidity, torsional strength, and aerodynamic load resistance during operation. Externally, a fiberglass finish layer is applied to smooth the surface, optimize airflow, and ensure overall structural continuity. The rear aerodynamic control surfaces are reinforced with carbon spars and small wooden inserts, acting as the primary load-bearing spine of the structure, significantly improving overall rigidity and stability during operation. In parallel, precision-machined wooden bulkheads are installed and bonded inside the structure, forming a reinforcement framework that distributes loads and enhances overall structural strength. Inside the control surfaces, electrical wiring and signal lines are carefully routed and embedded in a clean and organized manner, ensuring technical safety before the internal cavity is fully sealed. Subsequently, layers of carbon fiber and fiberglass are applied to the surface, forming a seamless, solid, and uniform composite structure, ready to withstand demanding aerodynamic load conditions. Following the completion of the rear control tail assembly, the main wing system also enters the stage of cutting, fabrication, assembly, and direct integration with the aircraft fuselage. The entire wing structure is carefully prepared and mounted onto the central fuselage with extremely high precision. As the wing assembly is pressed into position, all connection points align with near-perfect accuracy, forming a unified structure with exceptional rigidity and stability for the entire aerodynamic system. This stage also marks the synchronized completion of the rear control tail assembly before proceeding to the next phase of main wing integration and final structural refinement. With the tail control system completed, we began building the massive main wings, one of the most critical and complex structures of the entire aircraft. High-density foam blocks were first cut using a CNC hot wire machine to achieve precise aerodynamic airfoil shapes, then bonded together on a perfectly flat surface to form the full wing core. Once the wing core was shaped, internal channels were carved for servo wires, power lines, and navigation lighting systems. At the same time, a carbon fiber spar beam was embedded deep inside the wing to increase structural rigidity and prevent wing twisting under heavy aerodynamic loads. The entire internal structure was then sealed with high-strength epoxy, locking all components into a solid, unified assembly. After the carbon fiber and fiberglass composite skin had fully cured, the wing surface was sanded smooth and reinforced with additional composite layers in high-stress areas. Precise hinge slots for the flaps and ailerons were then cut, followed by the installation of ultra-durable Kevlar hinges bonded securely with epoxy adhesive. Finally, the moving hinge line was covered with a thin fiberglass tape layer to improve durability and aerodynamic smoothness, completing an ultra-lightweight, yet extremely rigid wing structure ready for flight testing. With the massive main wings completed, the project moved into the critical stage of building the engine nacelles and integrating the powerful EDF jet propulsion system. The nacelle shells were CNC cut from lightweight foam blocks, while the internal structure was reinforced with 6mm plywood bulkheads and motor mounting rings to withstand extreme thrust loads. Carbon fiber and fiberglass layers were then laminated inside the nacelles to create a rigid yet lightweight composite structure. Next, the EDF system wiring was assembled, including high current power cables and ESC signal lines routed through internal channels hidden inside the wings. Each wing was equipped with two massive Schubeler DS-215 EDF units, generating enormous thrust for the giant C-17 aircraft. The engine pylons were bonded with high-strength structural adhesive and reinforced with carbon fiber wraps to permanently lock the nacelles into the wing structure. Finally, the entire wing and engine assembly was fully integrated with the fuselage through a high-strength carbon fiber joiner tube system, locking all connection points into a single rigid and seamless structure. The giant 6-meter wingspan C-17 had now formed its complete primary airframe, ready for central electrical integration, battery system installation, and the final preparation stages before flight testing. After completing the test fit of the massive jet-powered wing assembly, we continued working on the aircraft's critical structural systems in preparation for the central electrical installation and heavy-duty landing gear integration. First, a large opening was precisely cut along the upper spine of the fuselage to create a spacious technical access compartment. The removed composite panel was then reinforced with durable hinges, transforming it into a functional hatch for maintenance and system access. Inside this compartment, the high-capacity LiPo battery packs, radio receiver, and the aircraft's main electronic control systems would later be installed. Next, the project moved into the construction of the heavy-duty landing gear system, one of the most complex mechanical assemblies of the entire aircraft. Shock absorbers, linkage arms, and metal support brackets were assembled in a scale-accurate configuration designed to withstand heavy landing loads. All joints were secured using structural bolts and high-strength adhesive, forming a rigid and highly stable landing gear structure. Once completed, the landing gear assembly was installed inside the fuselage belly and permanently bonded onto reinforced wooden bulkheads, using specialized structural adhesive. This reinforcement process evenly distributed landing forces throughout the airframe, providing the giant C-17 with the strength and stability required for upcoming high-speed taxi and landing tests. With the entire aircraft structure, from the fuselage and main wings to the heavy-duty landing gear system, fully completed, the project entered its final and most critical phase, installing the Central Electronic Control System. Power distribution modules, ESC controllers, and radio receivers were carefully organized on the main electronics board before every wire was cut, soldered, and reinforced with heat shrink tubing to ensure maximum reliability under high electrical loads. Once completed, the entire control system was integrated directly into the fuselage and connected to the high-capacity LiPo battery packs. The final assembly process then began as the fuselage, tail section, and giant main wings carrying 4 massive EDF jet engines were securely joined together using heavy-duty mechanical locking systems, officially forming the enormous 6-meter wingspan RC C-17 Globemaster. Before flight testing, a full ground operation test was performed inside the workshop. The flaps, ailerons, and tail control surfaces responded smoothly and precisely, while the 4 EDF jet engines simultaneously accelerated with an aggressive turbine-like roar. Finally, the C-17 was rolled onto the runway for its maiden flight. Powered by the immense thrust of the EDF system and supported by its ultra-rigid composite airframe, the giant aircraft accelerated powerfully, lifted smoothly into the sky, and performed stable flight maneuvers, marking the successful completion of this extraordinary engineering project. Watching the giant C-17 Globemaster glide smoothly across the blue sky after such a demanding construction journey made every moment of exhaustion feel worthwhile. From the ultralight foam core and durable carbon fiber composite skin to the reinforced plywood internal structure, every component worked together perfectly to create an airframe that was both lightweight and incredibly rigid. Even while carrying 4 massive EDF jet engines and performing fast sweeping turns, the enormous wings remained remarkably stable without noticeable flex or vibration. This 6-meter wingspan RC C-17 project was far more than just a large-scale engineering build. It became a true demonstration of passion, precision, and persistence. The successful maiden flight marked not only the completion of an extraordinary aircraft, but also the beginning of many exciting flights ahead for this giant transport aircraft.